Think you've already watched Tesla's humanoid robot show off its skills? Hit play on an 8-second video and you'll see why the crowd goes wild. Franz von Holthausen just makes a small gesture and Optimus Gen 3 walks out confidently, turns, kicks to the side, and returns to standing tall. No cables, no railings, and no loud motor noises. That calm performance opens the door to a bigger story. Tesla's robot Optimus has removed its safety frame, doubled its finger flexibility, increased hip strength by 4 times, and dropped almost 10 kilograms, passing rivals that still need tripods or stay behind curtains. In the next few minutes, we'll go through how quiet harmonic drives help it stay silent, how a 76 plus 34 centimeters balanced footprint helps it stay standing, and why its 45 kilograms carbon structure weighs half as much as Boston Dynamics Atlas. If you thought Optimus was just a showpiece, what comes next might change how you see the future of robotic workers around the world. At 8:31 p.m. on June 6, 2025, a silver and black robot walked out from stage left at the summit in Detroit. Franz von Holthausen gave a small signal, and Optimus Gen 3 responded with a friendly wave and a clean sidekick that shifted its weight perfectly over one leg. No cords, no counterbalance, and no safety rig. The crowd gasped and cheered. They had just seen 45 kilograms of carbon, titanium, and electronics hold its balance through a big move that could knock over most research robots. That 8-second clip, shared by Jason Raznick and reposted by Nick de Cruz Patton, quickly hit over 10 million views. Why? Because it showed something surprisingly normal, a humanoid robot acting like a confident person on an open stage. Why does doing it without cables matter more than doing a backflip? Human-like kicks are extremely difficult. The torso has to turn 90 degrees, the leg position must generate more than 1.2 times gravity's side force, and the robot has only about 300 milliseconds to shift its balance back to center or it'll fall. Optimus does this using closed-loop torque control that runs 1,000 times per second, relying on a predictive model powered by the same AI hardware that Tesla uses in its vehicles. The robot's 125 pounds, 57 kilograms, weight is distributed over a 173 centimeters tall frame, half the weight of Boston Dynamics Electric Atlas, which means there's less room for balance errors. Still, the kick is smooth, with no wobble. What also stands out is the silence. Every joint uses a direct drive harmonic system that cuts noise by about 15 decibels compared to the earlier version. This kick isn't just for show, it's a challenge that proves Tesla's system can keep the center of balance within a footprint of just 34 plus 76 centimeters, even while the limbs move forcefully. Go back to AI Day in 2022, when Elon Musk admitted that Optimus' first walk without support was the first time it worked without a tether. Just before that, the same model had been rolled on stage strapped into a safety rig for checks. 3 years later, the Detroit version walks freely, waves with individual fingers, and kicks, actions that force it to rebalance quickly and accurately. Tesla removed 12 kilograms of weight, swapped steel for carbon fiber with a honeycomb structure, and moved the entire control system into one main processor. This made the robot strong enough for a factory floor but still smooth enough for a live stage, exactly what customers will want when test programs start in 2026. Boston Dynamics Electric Atlas can also move untethered and precisely handle engine covers, but at 89 kilograms, it's nearly twice as heavy as Gen 3 and still needs external chargers between demos. Apptronic's Apollo weighs 72 kilograms and offers the option to be plugged in or tethered for longer tasks, a smart but limiting safety backup that wouldn't work on stage. Figure AI's Figure 02 model is being tested at companies like Barisha Motor and Vera AG, but it still operates behind curtains, walks slower than 3 miles per hour, and focuses mostly on bin picking. None of these other robots has shown a live kick or major movement test without safety barriers, which is why that Detroit demo feels like a big moment, not just a stunt. Having full freedom of movement isn't just about looking cool. It directly affects how much it costs to own and run the robot. A machine that doesn't need thick power cables or ceiling rigs to catch it during a fall can cut setup costs by big margins, especially for places updating older systems. Tesla is also planning to make these robots in large numbers. Internal goals still aim for a material cost under $25,000 once production moves to Giga Texas. In comparison, analysts estimate Apollo could cost between $150,000 and $250,000, and figure around low six figures. Combine Tesla's lower cost, lighter weight, fewer floor upgrades, and a control system already used in millions of Tesla cars, and you get the shortest path from lab to real work. Optimus didn't just show off, it stood on its own, completely untethered. Play Tesla's new video in slow motion and you'll see something subtle. Optimus doesn't just wave, each finger spreads, pauses, and closes again using slightly different curves. It can even make signs like "okay" or a curling motion to call someone over. That kind of control comes from increasing each hand from 11 to 22 degrees of movement, basically doubling the number of joints the computer can use. Elon Musk confirmed this last year, saying it's close to the human hand's 27-joint baseline. The difference is easy to notice and a huge deal for the robot's grasping software, since every extra joint adds a new way to hold unusual parts. The change comes from an entirely new design. Now, each finger has a frameless motor directly attached to a small harmonic gear, with sensors for both position and torque. A leaked breakdown of the parts shows this system: frameless motor, harmonic reducer, torque sensor, position sensor, and bearings. That setup gives Tesla three big advantages that are hard for others to get all at once: strong grip to lift a 20-pound box, soft control to hold an egg, and fast feedback that the AI can trust. These gears also have almost no backlash, which removes the clicking sound you often hear when lab hands change direction. This control shows up in the numbers too. Engineers say a full open-close finger motion takes under 250 milliseconds, about twice as fast as Gen 2. They also say finger motion repeatability is better than 0.3 mm because of the fast torque control. People who paused the video measured the thumb's side-to-side movement at around 34 degrees, letting it touch any finger pad, not just the index finger. Combine that with touch sensors on each fingertip, the same ones that let Gen 2 hold an egg, and the new hand can do delicate tasks like threading cables or placing wires, which Elon Musk says are next. Atlas still uses a specific three-finger grip design made for tough work and 20 kg payloads. While it can swap tips for different jobs, it doesn't have the same fine control. Figure AI's robot hand has 16 degrees of movement, still about one-third less than Tesla's. Early tests showed some difficulty with oddly shaped parts. Apptronik's Apollo has a prosthetic-style hand with only 5 motorized joints, which limits how well it can adjust a grip while holding something. Each robot is making trade-offs between fine movement, toughness, sensing, and design complexity. But Tesla now seems to be the only one combining full 5-finger tendon control with powerful feedback. Breakdowns from Foxtech Robotics say the tendons in Gen 3's hands run through ball screw actuators in the forearm. That setup keeps the motors out of the fingertips and still reaches all 22 joints. When you add Tesla's real-time vision system, borrowed from their full self-driving tech, you get hands that can pinch a washer, hold a half-liter bottle, or lift and twist a 10 kg battery into place. These actions need both soft control and strong holding force at the same time. What would you do with Tesla Bot Gen 3 once it's available? And is it finally time to take it seriously? When people imagine humanoid robots, they often have one of two reactions: they're either excited about never doing chores again or worried that robots will take over jobs, or even the world. Then there's a third group that just laughs at the idea, seeing robots as awkward machines that stumble around like someone half asleep, or worse, like a politician fumbling through a speech. And honestly, it used to be hard to take most humanoid robots seriously. But something has shifted in the last 2 years. The progress isn't just slow improvements, it's major breakthroughs. Tesla's Optimus Gen 3 has gone from an idea to a working robot that could soon show up in homes or offices. Unlike flashy demos that vanish afterward, Tesla's goal is mass production and real-world use, putting it far ahead of the pack. At an event that was mainly for showing off Tesla's new self-driving car, the Cybercab, Optimus unexpectedly became the star. Dozens of the robots were there, greeting people and showing their abilities. This wasn't about showing off, it was Tesla saying this robot is meant for everyday tasks. So what can Optimus Gen 3 actually do? A lot. It can inspect packages, fold laundry, water plants, serve drinks, clean, charge your Tesla, and even play with kids or dance. It reacts to voice, touch, and hand signals, so you don't always need to talk to give it commands. Elon Musk confirmed this, saying you can customize its voice and personality, and it'll learn your habits. You won't always have to give instructions, it'll just get what you want. What makes all this work is Tesla's strength in real-world AI. The same intelligence that drives Tesla cars is now powering a human-shaped robot. Musk compared it to the Tin Man in The Wizard of Oz, except this one has a working brain. Optimus can watch a video of a task and copy it, whether it's cooking or dancing. You won't need to code anything, just show it once and it learns. Sure, the robot isn't perfect yet. Like any new tech, it has bugs. Musk admitted that early models might mess up, like bringing you an empty plate instead of food or slipping on stairs. But Tesla is known for fast progress. They went from a few hundred Cybertrucks to over 3,000 per week in less than a year. It's likely they'll fix the issues quickly. The fact that Optimus already corrects its own mistakes, like picking up dropped items, shows how advanced it is. Another major difference is the physical design, especially the hands. Musk said almost half of the engineering effort was spent perfecting them, not just for strength but for precise, human-like movements. The previous version had only 11 joints in the arms and hands. Gen 3 now has 22, making it much better at small and tricky jobs. Most other robots use claws or basic 2- or 3-finger designs, but Tesla wants full human-style hands with 5 fingers and realistic motion, even finger-length differences like in real hands. Why? Because this kind of control lets Optimus handle everything from heavy boxes to fragile glasses and pens. This opens it up for homes, elder care, factories, and even future lab or surgery work. Tesla's also planning big production numbers. While others build one robot at a time, Tesla wants to launch 5,000 in the first batch. Musk said they hope to grow that quickly. If that happens, and yes, Musk's timelines can be a bit hopeful, Tesla could make 1 million robots a year by 2027. That would make humanoid robots affordable for regular families and businesses, not just the rich. Price matters too. Musk said you should be able to buy an Optimus for $20,000 to $30,000, about the same as a new car. That would make it realistic for homes, small companies, even schools. Owning a robot might not be a distant dream but a real option soon. All of this shows Tesla isn't just a car company anymore. It's becoming a robotics leader that could change the job market. These robots could work in warehouses, help in hospitals, or take over boring factory tasks. That could lower labor costs, make workplaces safer, and let people focus on more meaningful jobs. Musk believes Optimus might be Tesla's most valuable product ever. That might sound extreme, but the idea is clear. While the EV market is now full of competition, almost no one is seriously competing in home or work-ready humanoid robots. If Tesla pulls it off, Optimus could become as common as a smartphone or laptop. So, is Tesla Bot Gen 3 just another robot with cool moves? Or is it a smart, helpful machine that learns from people and improves with experience? After seeing that smooth, untethered kick and those fluid hand motions, do you believe it's more than just a flashy prototype? Or are you still waiting to see it in real life? Let us know your thoughts in the comments. Thanks for watching. If you want more updates on Tesla EVs or the Tesla Bot, hit like and share this video. Don't forget to subscribe to Tesla Car World and turn on notifications so you never miss what's coming next. We appreciate your support and can't wait to see you in the next video. Goodbye.